This is our last video in section 1.1, and we're going to finish up the last 2 pages in our workbook dealing with this. So, start off. In example 11, we're given 2 functions, f of x and g of x, and we're to do different things with them. So the first one tells us to find the values of x such that f of x equals 0. Once again, this is the zeros of the function. When y equals 0. That's what we're looking for. So we're going to have f of x equals 2x squared plus 5x minus 7. We're going to say that equals 0. So we're going to find the zeros of the function. And I'm going to go over here to my calculator and I'm going to plug it in and see what it gives me. Wow. We've got a small problem right here. You see that? Now, once again, if factoring is not a problem for you, you can take a look at this and possibly come up pretty quickly with what the factors are. Let me just go through the factoring and then we'll go over here and see how we can find it with our calculator. And what I'm talking about is when you're entering your answers on our homework software and on your test, it is not like approximations. It would prefer you to give them the exact value or a whole lot of decimals. So we can't just look at that and say, oh, that's between -3 and -4. I'm going to take a guess. You can't do that. You've got to figure out the decimal approximation. At least that's what your calculator will give you of that value. So I'm going to go over here and do this algebraically. I'm looking for the factors of 7 that subtract, give me a 5. So the factors of 7 that have 2 different signs. So factors of 7 are 7 and 1. And if we want to get a positive 5, there's a positive 7 and a negative 1. So we have 2x plus 7 equals 0. And x minus 1 equals 0. So 2x equals -7. And x equals a -7/2. And then x equals 1. So there's our zeros. When x equals a -7/2, which is a -3.5. And when x equals 1, our function, our y values are at 0. Now, let me just go over here. Zeros. Sorry. X equals -3.5 or 7/2 and positive 1. That's our answer. Now, on our calculator, we have this right here and we've graphed it. If you want to find the zeros, there's several ways you can do it. But a lot of people are very fond of the calculate menu. So what that does is you go into that menu and you can find certain things on your graph using the calculator. And in this case, we want to find the 0. So I'm going to hit number 2. And it's going to say left bound. And what it's talking about is along the x-axis. Move your cursor to the left along, when I say left, in relation to the x-axis. The left of the 0 or the x-intercept you're interested in. So once you've got your cursor moved or your little spider moved where you want it, hit enter. And it drops an anchor. So it's going to try to find the 0 from this left boundary, which the calculator says is this. And it wants us now to find our right bound. So I'm going to move to the right of the intercept, which once again is in relation to the axis. So to the right on the axis. I'm going to hit enter. It's going to drop another anchor. Then it's going to ask for a guess. And a guess is just in case you have your anchor spread way out. It helps to narrow it down faster. But most of the time, you can just hit enter. And there it is. The 0 is at -3.5. All right. So if we did that again, second trace, number 2 to find the 0. I'm going to go find the 0 on over here, which we know is positive 1. But for our calculator, it says left bound, so I'm going to move across here, coming in from the left. I'm going to make sure I'm to the left in terms of the x-axis. Hit enter. Right bound, I'm going to get above the axis. I'm going to get to the right along the x-axis. Then I'm going to have a guess. And it says, there you go, your 0 is 1. So you can use your calculator to find where it crosses the x-axis. And then also, you can use your calculator to find where two functions have the same y values. Now, algebraically, I'm saying this is where 2x squared plus 5x minus 7 is equal to 2x minus 2. And then you can just solve this if you want to, algebraically. But you can also use your calculator. You can put the two functions in, 2x squared plus 5x minus 7, and then 2x minus 2. You can hit graph, and that line is going across here. And then we can go into our, what we're looking for on this graph is where they intersect. That's where their y values are equal. Right there, right there. So we're going to go into that menu again, and we're going to find intersect. So second trace, number 5. And then it's going to say first curve, and the spider is on this parabola, so that's my first curve. Second curve, spider moves to that line, enter. And then it says guess. And this, you do need to move your cursor to whatever intersection you're interested in. So I'm going to move it to the left. I want to know that intersection, negative 2.5. And then I'm going to go get this intersection. So we're going to do second trace, number 5, intersect. And first curve, enter, second curve, enter. And I'm going to move my little spider up here. I guess it's there. And the intersection is at 1. So if I solve this equation, I should get this answer. So to solve this equation, I'm just going to move 2x and 2 over to the left. This, of course, goes to 0. And I have 2x squared plus 3x minus 5 equals 0. And then I'm going to factor this. Looking for the factors of 5 that have different signs that subtract to give us a 3. And there it is factored. And then you would separate it. 2x minus 5 equals 0, and x plus 1 equals 0. And when you solve those two linear equations, you get negative 2.5 and 1. And those are the intersections of the two graphs. So once again, second trace 5 takes you into intersect. And second trace 2, I believe, yes, 2, gives you the y-intercepts, the zeros. On example 12, we are given a piecewise function. And a piecewise function is a function that has two different expressions along the number line. Or it can have more than two. It can have multiple expressions. But this particular piecewise function says it's a parabola to the left of x of negative 1. And it's a line to the right of 1. Notice the equal to is right there with that negative 1. So we're going to do some evaluations. And in a minute, I'll throw it on the graph so we can look at it. But f of negative 2, we go over here first and we figure out which piece of the graph matches where negative 2 would be. And the first piece, we're looking at values of x smaller than negative 1. So it's going to go into the first piece. So for this one, we're going to evaluate it x squared minus 1. So f of negative 2 is negative 2 squared minus 1, or 4 minus 1 is 3. F of 3, we go over here to our graph. 3 is bigger than 1. So for this particular one, we're going to evaluate 2x plus 1. So f of 3 is 2 times 3 plus 1, which is 7. And the last thing we're to evaluate is f of -1. So once again, we go up here. This -1 is equal to -1. So we're going to evaluate the function x squared minus 1 at -1. And that equals 0. On the last page of section 1.1, we have example 13. And it says to find the domain of the following functions. So you take a look at the functions, and we have a square root, and we have a special rule for or special way to handle the domain for a square root. We have a fraction or a rational function, and we have a special way of handling those. And then notice we have a square root with a fraction, so that's going to be fun. But let's start with A. We have the function, the volume is equal to 4/3 pi r cubed, and we want to say that represents the volume of the sphere of a radius, of a sphere of radius r. Well, r can be anything it wants to be, right? Does that make sense? 4/3 and pi, they're just numbers. Pi is approximately 3.14. R cubed is just some number cubed. So that means that the domain is all real numbers. So negative infinity to infinity. If you wanted to graph that, we could. We have 4/3, and then pi, it's right over here. And then I'm going to use x cubed. Let me hit graph. And there it is. That's a representation of all of the values that you could plug in. So the domain is all real numbers. On this one, the square root, the radicand, or the part underneath the square root, has to be non-negative. So to find the domain, we say that it has to be greater than or equal to 0. Solve this guy, and we get 2x is greater than or equal to 1, and x is greater than or equal to 1. So the values I can plug into this and keep it larger than or equal to 0 are from 1/2. Oops, that should be included. Hard bracket, because the 1/2 has an equal to right there. 1/2 to infinity. So that's our domain on that one. On this one, this is the problem. The denominator cannot equal 0. The numerator can be what it wants because it's just 2x plus 1. But the denominator cannot equal 0. So however you want to do this, if you want to factor it, this is what it factors to. So x minus 4 cannot equal 0. And x minus 1 cannot equal 0. So x cannot equal 4 if x cannot equal -1. So the domain is from negative infinity to -1, union -1 to 4, union 4 to infinity. That's our domain. And once again, I got it this way because if you graph it on a number line, -1 to 4, x cannot equal -1, x cannot equal 4, but it could equal all the other numbers out there. So there's my -1, this is my negative infinity to -1, and -1 to 4, and then 4 to infinity. If you wanted to put it on your calculator, I'm just going to take the denominator. I'm not going to look at asymptotes. I'm going to look at where the denominator hits the x-axis, where the y value equals 0. And once again, by inspection, oh, pardon me, I'm glad I did it on the calculator. That's a positive one. Did y'all catch that when I was doing this on the video? I apologize. That is a positive one because we add 1 to both sides. So that should be a positive one, and that should be a positive one, and that should be a positive one. I apologize. So by inspection, this graph helped me see that I had not applied that negative correctly. Our 1 and 4 is where the denominator hits 0. And the domain can be everything except where the denominator equals 0. On this last one, we have a combo going on. In the numerator, 2x plus 4 has to be larger than 0. And then in the denominator, this cannot equal 0. So to solve this part, 2x is larger than -4, and then x is greater than or equal to -2. To solve this one, x cannot equal 3. All right, so let's put this on a number line so we can figure out our domain. -2 and 3. -2 is an open circle because it cannot equal 3. I said -2, I apologize. 3 is an open circle because it cannot equal 3. X is larger than or equal to -2, so it's a closed circle, and it's bigger, but it can't equal 3, so we're going to have to skip over that and keep on going to the right. So that means my domain is from -2 to 3, and then skips over 3, picks up right on the other side, 3 to infinity. I hope working through these problems helps you as you go through your homework. You'll be asked to do similar problems. If you have any trouble with it, please send me an email or send me a Blackboard message, and I will get back to you as quickly as possible.